In previous videos I built a scaffold with wheels on it, but now I want to motorize it so I can drive it around without climbing down. I'm going to use this slow speed half-inch drill, and that's going to drive this little pulley which will drive a V-belt, which in turn will drive a bigger wheel. I want to make a disc that's a little bit bigger than this. It's about that size here. So I need to stay this far from the edge, from each edge, to make sure I can still cut a disc. Right here should be safe for a center. And there's one disc. Let's do another one right about here. I just glued 3 layers together. The top is a bit smaller, and I used a nail through all of them to keep them aligned. And now I'm going to use a drill to provide an axis to spin these on. I now need to cut a V-belt groove in here, and I've jigged this up on the table saw with a backstop and a fingerboard to make cutting that slot slightly less dangerous. After a whole lot of milling on the table saw, I'm left with this. The important thing is that when the belt rides on there, it doesn't ride on the bottom, but on the sides. The wheel is going to mount between those two things here, and I've got bronze bushings in here for bearings. Washer on either side goes in here, and this is temporarily screwed on here, and then a small pulley on here is going to get driven by my drill here. This runs just in the wood here, and I've got a screw here that goes in a barrel nut in here for tightening the belt, just to make sure it doesn't slip because there might be a lot of torque on it. And then the drill is mounted just by the chuck, and to keep it from spinning, there used to be a handle here, but I'm just using a bolt instead, so that goes in here. It only runs at 550 RPM, and it has a trigger lock, so now if I plug that in, that should turn the wheel. This motorized assembly goes on the end of the shaft, and the shaft is supposed to turn to allow me steering of the scaffold, so I want to create a round section right here. Well, it didn't need to be totally smooth. That's about as good as I was expecting. I'll clean it up with a rasp. And that steering column rotates on these very loose wooden bearings, and I cut these out on the bandsaw because I didn't have a drill big enough to drill these holes. Here's my finished propulsion unit and steering column. This couples and it goes further up, so that way at the very top of the scaffold, here's my steering tiller, which allows me to rotate the whole assembly. And normally this thing won't be load bearing, but if I want to drive somewhere, I'm going to use this lever to push that steerable wheel down and transfer the load onto it. And this is going to screw onto the framework of the scaffolds. Alright, drill is mounted. Let's give this guy a test drive. So up here is my steering tiller, and when I push this thing down, that pushes down on the wheel and essentially turns the scaffold into a tricycle. It is a little bit wobbly in that configuration. But here's the magic thing that's going to make it safe. It's a Variax speed controller. Alright, okay, here we go. We're running. Uh-oh. I need to flip that around. I can go a bit faster than that. Whoa! Okay, time to go a little bit faster. Forward again, 80% power. The scaffold does not corner very well. It's a good thing the scaffold is fairly climbable, because when I parked it, I was quite a ways from my stepladder. Alright, this time with 100% power. Let's see how it goes. Whoops, ran over the extension cord. You know how in movies and car chase scenes, sometimes they show the front wheel as it steers? Well, let's pretend we're having a scaffold chase. Well, that was fun, and I have to admit, that actually worked better than I thought it would.